Haystacks Tech here. So this is going to be the demo, a product demo of the portfolio of solutions that are provided by Haystacks Tech. And yeah, we're just going to get right into this. So I'm just going to give you an overview of what the products are, and then we're going to dive into the actual demo of the product themselves. So what the products are named, and what their purpose is, how they're used, and then sort of how they work together. So all of these tools are built on the Haystacks asynchronous development platform, which is itself in the previous demo, the Haystacks webinar 1. So that is another video, which I guess I can link in here somewhere. You'll probably see it in the video description as well. And so what this is, all of these products are built on top of that development platform. And so what we're looking at here is the main product that we're going to show is Hay-CAF, which stands for Haystacks Cloud Automation Framework, and it is essentially a test runner. It is designed to run on Mac, Linux, and Windows. With that in mind, keep in mind that it can run on Docker, Kubernetes, on AWS environments, and it is 100% MIT licensed, completely open source. And it is a great example of how to build an enterprise application using the Haystacks asynchronous development platform. Again, that was showed off in the Haystacks webinar 1 video. Given that, the other products that are built on top of this are Hay-DCAF. That's Haystacks Data-Centric Automation Framework, and that is a GUI, graphical user interface, so it's a web testing automation framework. It uses tools like Playwright, Puppeteer, Selenium, WebDriver IO, and it has a hook for you to build your own WebDriver. So I've sort of stubbed out that. So if you needed to build your own WebDriver and you didn't want to have Playwright as a third-party dependency, you could remove Playwright and Selenium and whatever else as your third party if you wanted to build your own from scratch. We provide that, so that's in there. And Hay-DCAF works with Hay-DCAF, and so that's what we're going to demo today. There is another framework, another testing framework called Haste, which we will also demo at the very end of this demonstration. Haste stands for Haystacks Service Testing. So Haste is an API testing framework. So that allows you to test your microservices, your web services, your REST APIs. And it is built with tools like Postman, Newman, Axios, WebDriver. I'm sorry, not WebDriver. It's built with async request, and node fetch. So it uses all of those. That's another 6 or so tools that you can use. And most people are using Postman or Newman, but we've essentially captured the JavaScript interfaces for those, and we've wrapped it inside of our own data-driven architecture, which is what we're going to cover today. I also have started to build the Appium system, which is going to be called Hay Mobile. We didn't get that far yet, so that product's kind of on hold right now. But then in addition to that, we also have Hay-BDD. So that's Haystacks natural language driver engine, which is like a Gherkin code. It's be similar to Cucumber or those kinds of tools. And then we've got a Hay Plan, which is test plan automation, optimization, and test planning system. So it optimizes your test plans. And I'm getting a little bit off in some of the other products. There's Hay-Waka, which is Haystacks Web Accessibility Compliance Automation. And then there's another one for Hay-Monkey for fuzz, for monkey testing and fuzz testing. And also Hay-Load for load testing. So those are additional planned products that we haven't built yet. But we definitely do have the Hay-DCAF for Playwright, Puppeteer, Selenium, and WebDriver IO for browser automation, and the API testing framework. So we're about 90% done with the API testing, and I'm going to sort of show that off a little bit. You're not going to see very much. It's mostly the developer all the developer commands and full, I guess what would you call it? verbose debugging is enabled. So you're going to see sort of under the hood about all the data that's being processed and generated on demand. And we're going to sort of see how all of that stuff works. But because this is a very, very, very advanced framework. So let me get into it. Essentially, it is a no-code testing automation framework. Now, a lot of people, you hear the word no code and say, nope, I'm out. Forget it. I'm not interested, right? Because if it's no code, then I don't have control over the code, and I want to maintain controller because I'm a developer. And they say, well, what about AI? Okay, we don't have AI in because we felt that AI wasn't reliable enough. It generates too many hallucinations. And I try to build systems so that they are so reliable that you could trust it to build your airbag, to write this code for your airbag or your pacemaker or your nuclear power station, right? I'm not going to trust an AI to write the code that runs in my airbag for my car or my pacemaker. If I had a pacemaker, I wouldn't trust AI to write that code, right? Not when your life depends on it. And so I try to write reliable software that runs for military specifications, those kind of levels of requirements. And so you can only have the top level of your requirements can never exceed the maximum that the reliability of your QA system itself. So if I'm going to try to achieve reliability that is at that level, then my QA system needs to be at that level as well. And so that's why I try to build systems at that level of reliability. So given that, that's kind of what goes into building all of these things. And like I said, it is a no-code framework. But when we say no code, you can say, most people, like I said, think I'm out. Nope, I'm not interested. The reason why is because they feel like they've lost control. That's not what this is. This is no code with the code. Essentially, when you become a customer of Haystacks, you get our source code. You own it. You buy it, you purchase it, it's yours. It's just like buying Microsoft Word or Microsoft Office 365. You can buy a subscription and you're stuck with an online, you can only access it online, or you can buy the one that comes on a little thumb drive and then you own the installer. You can install it on any system. Of course, Microsoft tracks how many installs you do. That's separate, right? But you paid for the license and you can install it wherever you need it and use it, offline. So that's kind of what this is. This code allows you to install it inside your business. You just download it and install it on your premises, right? And so we feel that's really good and really important, especially for customers that are doing something with pharmaceuticals or healthcare or health insurance or certain banking institutions, government regulators, or any type of military applications. Those kinds of things need to be run on premises, and so they can't have a lot of third-party dependencies. They need to be downloadable and installable on premises, completely remote. So that's kind of what we're looking at here. And so it is no code, but you get the code. Like if you feel that there's something that isn't working quite the way you want it to, by all means, go and enhance the code, write your additional own rules and customizations and whatever it is that you want to do, and you didn't lose control of the code. But it does provide an interface for you to do that. And so that's what we're going to sort of get into. So this framework is a rules-based engine. It's an expert system. And so that's what we're going to get into. So let me go ahead and turn off my camera and share my screen. And we're going to get into Hay-DCAF. Now, the reason why we're going to get into Hay-DCAF first is because if I just run the thing, it's going to go so fast and you're going to have no idea what displays on the screen, and it's going to just race past and you're not going to necessarily understand what it is that you even see on the screen. So I'm going to walk you through a little bit of code, just a tiny bit. I know I said it's no code, but we need to have a tiny bit of code just to sort of get things to get up and running. So I'm going to walk you through that, and then I'm going to show how that tiny bit of code that I do show you leads into the data. So I know that you may not necessarily be as a prospective customer or somebody that might be evaluating different QA testing automation frameworks. If you're a business executive or a leadership in leadership or on the board of directors, you might not know what code is or what it looks like or how it runs or how it works. And that's perfectly fine. Like I said, just bear with me on the code. I'll try to get through that as fast as possible. We're going to get into the data, which is a little bit more agnostic and not quite as technical as having to understand code. And then from the code, once you start to understand the data, then we'll see a little bit better about how the workflow actually goes and how this can impact and save money for your business while giving the reliability that AI will never give you. Let me also state this is a data first framework. So data first is our approach, and that data first strategy combined with the expert system and the intelligent domain specific knowledge that is built into this framework would allow AI to be built on top of this system with much greater reliability than just putting AI straight onto a Playwright, or for instance, or capturing some of these other AI testing automation tools that are popping up like cardboards all over the place. They're little stand-ups, most of them sort of just clones of ChatGPT, and they're not built with the domain-specific QA intelligence that is needed to really test in a reliable way. So they're going to generate a lot of hallucinations, which is exactly what the industry has seen, and that's exactly what I've been saying for the last 10 years. I have been an AI scientist for about the last 10 or 15 years or so, starting back with IBM Watson when I was working for IBM. So I have quite a bit of history with AI, and I've been writing QA systems for about 25, 26 years, and I've been a software engineer and a computer scientist for about a little bit more than that, probably about 30 years. So I've got pretty deep experience, and you can find my profile on LinkedIn. Again, look in the video description to find those links. All right, so let's get into this. First of all, we do have to have a default test.js. Let me turn my camera off. So this is the Hay-DCAF repo, the code repo. And we've got two folders, sort of at the highest level. There's this source folder, and that has the source code. Inside there, we've got this framework folder, which is the testing framework itself. That's the code that drives everything. And the test bureau. Now, the test bureau is where you're going to have your site-specific test data, essentially. And I've got a site-specific that's called Haystacks Tech, which points to the Haystacks Tech website. So we've got default.test.js, which is sort of like the landing spot for the testing. So we run this as essentially the boilerplate entry point for the test. And so I'm going to go in here, and we're just going to breeze through this code very, very quickly. Again, I understand you're probably not into code, and that's okay. So just bear with me. All of this right here is a header. So this is basically a bunch of notes about what this file contains, and it indicates the file name, the module description, a whole bunch of requirements, third-party dependencies, that kind of thing. These are externals dependencies. These are internal dependencies. And these two are externals that are coming from Haystacks. So this is our organization has provided these. The rest of these are third-party. I've got some copyright information and a few notes about like just manual testing of this file. These are the actual imports, and then there's some global settings right here. There's this bootstrap function, bootstrap test environment. So that actually provides the bootstrap to get this thing going. The whole test environment gets up and running there. And it does a bunch of configurations. Like there's dev configuration, a production configuration, and then these are the decaf configs. So these are test specific page data, test paths, keyword paths, locator paths. That's all provided here. We call init framework there, and then we init the test framework here, which calls this warden. That's internal to this internal here, and that's the end of that bootstrap function. Okay, we got another one here called the application, which is the actual application. Now, this Hay-DCAF, it is an application. We called it a framework, but it's actually an application. It's sort of like an application wrapper. We use the test runner to call this to do the testing. All right, so the application, it does a few other things here to sort of get things up and running. It enqueues the startup workflow based on whether or not we've passed in arguments. So it's got an argument-driven interface versus an interactive interface. You can run this, like I said, as an application with an interactive interface. Just the same way that all Haystacks Haystacks Tech applications built on the Haystacks asynchronous development platform can run interactively with their command environment. But it'll also process with arguments, so process arguments. And in the case of automation, that's exactly what we're doing. We're basically passing arguments into this application. And the arguments are generated by the runner, which is the Hay-CAF. So that's how they integrate. And so let me come down here. It does a bunch of other things. And there's another bootstrapped here, some more configuration settings. And then it calls this execution engine. It switches on that. And I've got a stub in here for Appium, but this was to be removed because we're going to move this over to another product. Like I mentioned earlier, we're going to call it Hay Mobile. So that's going to move over to there. I was just using this to sort of be as an example to make sure that it was, so this was like my prototyping. This was the JavaScript stub if you wanted to build your own. And then we've got Playwright, Puppeteer, Selenium, and WebDriver IO. Otherwise, it's an unknown tool, and we throw an error message. So when it goes to Playwright, for instance, that's what I'm going to run, and it calls Playwright Boilerplate Test. And that's in the Playwright driver. So we go to drivers, and we're going to see that, what that looks like. I'm going to go into that in a minute. Let's finish this off. Come down here. There's some stuff on test status. It's sort of error handling and reporting, and it checks to see if it's started or undefined. Then that means it failed. And then it finally reports that, and it determines how it's going to exit, or how it should exit, or even if it should exit based on a configuration setting. Okay, so if it errors out, of course, it errors out and crashes, essentially. And then there's the argument-driven interface is false. So it's not, if it's not argument-driven, this means it's interactive, so it goes into a command loop. And it'll prompt for a command, it'll execute commands, and you can do it interactively. So that's what we do there. And then this is where it's actually run. So we set program running equals false. We call that bootstrap environment. We set program running true. And then we call this application to actually run the app, which is this Hay-DCAF app, right? So that runs the actual test or the interactive environment, depending on which mode you're in. Okay, so we've gotten past that. Let's come back up here to this Playwright boilerplate test. So if I go to drivers, playwright.test.js, this is the boilerplate. Okay, again, there's a bunch of header here, a bunch of imports, some globals, and this is the actual function, boilerplate test. Okay, let's look at this. You'll notice if I come back here, there's no input to this function or any of these functions, right? If you're running Selenium, it's not running, there's no input to this function. And this is the part that's actually doing the test. If I come here, again, no input here. It's the same function, right? And it's going in here. It's checking to see if it's a comma in the test name. If it's a comma, then it's a list of tests, and it'll go through a for loop and iterate over a whole list of tests and execute all of them iteratively. If it's not, then it's just a single test. It'll execute that one test, and then it's done. But it calls this common workflow. Notice again, in this case, no input to the function. Okay? So let's go down here. This is the common workflow function, no input. And it calls this a final setup test. There's one last setup call that need to be made. And then we call the primary workflow loop. And then from here, it's calling this as input the playwright test. It's just passing the word playwright. This is a constant. It just resolves to a string literal playwright. Playwright. That's what this resolves to. And so that's not really much of an input. Like that doesn't tell you like what tests should run or what input should be provided or what data scenario or what workflow should run, or like that doesn't tell you anything. And so the question next would be, well, how does it know what to test? Like this is the workflow. This is when it's actually running the test. So what's it testing? Well, the key is it figures out what it's testing from the test name. And it pulls the test name from this individual test name, which comes from a configuration setting. So test name array comes from there, which comes from test name preprocessed, which comes from this get configuration setting, which is test name preprocessed, which was set up here, which comes from this argument-driven interface. Okay, somewhere up in here somewhere. I forget exactly where. It's somewhere. But yeah, so that's where that's coming from. The test name is passed in as an argument to the input to the app. And it's going to figure out, oh, well, that's what tests we should run. And it looks up those from the list of tests. So here's the list of tests. In this case, there's a login submit, test_login submit.csv. So that's the only test that we have. If there was a big long list of tests here, and I told it to do the login test, then it would look for all through all these files, and it would find the one that has the keyword login in the file name. And it'll look that up and it'll say, aha, there's the file. That's the one I want to run. And it'll run it. That's what the runner does. Okay, so let's look at this. This is a CSV file. You've got keyword and row number. So it's a keyword-driven framework, and it just runs through each of these keywords sequentially from top to bottom. And here's the first one, home, public, home, nav. Okay, so now normally when you would go to your keyword-driven framework, your keywords, you could write this test definition as a BDD, Gherkin code, natural language. You could use AI to drive it. It doesn't matter. This data still needs to be provided somehow, some way. So you got to get the keyword. And normally your keywords would be code. Like if you're working in Selenium, most likely your keywords are written in Java code, right? If you're working in Playwright, it could be C#, it could be JavaScript, but it's typically code that your test engineers need to write. They need to sit down and understand how to write code, or maybe you're using AI agents, and the AI agents need to know how to write your keyword code. Well, let's go look at this. This is our keyword, home, public, home, nav. So we go to the keywords, and there's home, public, nav, home, public, home, nav. Here it is right here, .csv. Well, that's also a CSV. Okay, so this keyword definition is not code. Like I said, this is a no-code driven framework. So what we've done here is we've taken the keywords and applied the principles of a keyword-driven framework here to the definition of the keywords themselves. So this is a rules-based engine. And so we've got execute, action type, page name, element name, action override. These are the columns, right? So here in the first row, there's a true, GUI, there's the page name, annotation is the element name, and we're going to say begin test. Okay, so we got some annotations that are pre-programmed into the framework. Begin test is just going to report, hey, we're beginning the test, and it's going to annotate the log. Okay, we come down here, there's another annotation, begin keyword. It's indicating when we begin the keyword, what keyword begins, and maybe what timestamp it begins, and that kind of stuff. Okay, we come down here to the next step in the keyword, in the keyword definition, and we have URL. Okay, so again, this entire framework is built on, it's a rules-based engine, right? It's got an expert system. The expert system is built on a system of heuristics and sort of business rules and behavior logic. Now, the behavior logic is a schema. It's a schema-driven behavior. So there's a schema engine that drives this as well, that drives these behaviors. And in the schema, this is going to look and say, aha, we have a URL. Well, what would be the default behavior for a URL? If I just gave you a URL, what are you going to do with it? Like, if I just give you www.cnn.com and I tell you there's the URL, what would you do with it? Normally, default behavior would be, okay, I'm going to put that into my browser and type it in and press enter and navigate to it. Okay, that's exactly what this framework is going to do. It's going to say, okay, I've got a URL. I'm going to take that URL and I'm going to put it in the browser and I'm going to navigate to that URL. Well, where is the URL? It's not here. We got to have a www.something.com somewhere, and it's not here. So where is it? It's in the data. So we go look at this URL. We're in the home public. Okay, this is the page name, home public. So let's go to resources, data, page data, home public. Here's the URL right here. So there's the URL. That's what we're going to navigate to because default behavior, right? Okay. Now the next step, let's go to the next step. It says product. Assert exists. Okay, so product sounds like a title or something like that, maybe on the page. And we're going to assert exists means make sure, or assert, validate that that exists on the page, that it is present, that it can be seen, that it is visible, all of those things, right? Let's say maybe this was not a title. Let's say that was a button, right? And let's say instead of this assert exists, maybe this was also default, okay? Well, if this was a button and this was default, what would the thing do? Well, if I just give you a button, what would you do? You'd click on it, right? So normally that's what this would do. It takes the type of element that it's interacting with, and it will create a line of code on demand in real time as it's running to the default action. Now, in this case, it's an assert exists. So it's going to write a line of code that says product should exist, right? And it is writing the code on demand from data in real time using these heuristics-driven interface. So where do we get the product? Product is not a URL, and it's not an annotation. It's an element on a browser page. So we need to be able to uniquely identify that element to get to it, to figure out how to interact with it, to make sure that it does assert. So we go to locators, and we're looking for home public. There it is. Here's product. There's the value. This is your CSS locator. That's how you uniquely identify the element on the page. There's other things like nth, with text, product, type. Oh, it is a button. Okay, visibility check true, and a timeout 5,000. So 5,000 milliseconds. It'll wait up to 5,000 milliseconds before, if it's not immediately available. After 5 seconds, if it's still not available, then it will throw an error. And if it's a failure, then on failure, we indicate that we're going to fail. So you have control. If on this, maybe you want to change it to warning, or maybe you want to change it to pass, to ignore it. So you have that control here. Visibility check makes sure that it's actually on the page, that it exists, that it's interactable, it's visible, and you could actually click on it if, in this case, oh, it is a button, so you could click on it. With text indicates that it has with text product, and again, that's the CSS selector. That's how you uniquely identify the element on the page. I would highly recommend not to use XPath locators. CSS is much more reliable because the style of your page typically doesn't change as often as the XPath might. XPath will typically change if you're on a phone and you rotate your phone. Your XPaths are probably going to change, and your QA automation is going to break. I wouldn't recommend doing that. Your CSS is much more stable in that regard. Okay, so let's come back here. We got assert exists. So it's basically going to make sure that that CSS path object exists on the browser and assert that it's there. But you get the idea. It's going to interactively create lines of code on demand in real time using a behavior-driven schema that's a rules-based engine to determine how and what should be automated, completely keyword and data-driven. So that's what I mean when I say data first. It's the data that's driving the composition of what should be automated to begin with. So essentially what we've done is we've built a data layer that allows us to data automate the QA automation. We're kind of using automation to automate the automation, which is a precursor. In this case, it's a data-driven precursor to running this entire thing from AI. Given that, what we've done is, because we've built this data abstraction layer, is now we can lower the technical lift that an AI agent would need to be able to do this all of this work. It doesn't have to do as much work, much technical lift. So that's going to make the AI agent way, way more reliable, like orders of magnitude more reliable, multiple orders of magnitude more reliable than a traditional AI agent that is writing all of the AI code from scratch, right? This gives that extra layer. It gives context-specific domain information and lowers the technical lift. It gives greater amounts of data. And in addition to that, it's not just writing the lines of code for each of these lines right here. It's actually writing 2 lines of code. In this case, also notice this is false. So we've got execute true, 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 false, false, true, true. You can enable or disable individual lines here. So you can turn these on or off. So wanted to call that out as well. But it's not just writing these individual lines of code, okay? What it's doing is it's going to, for every single one of these lines, it's going to write 2 lines of code, okay? It's going to write one that is a text line of code, as if you, as the developer, had typed in the script code for this line right here with the URL, await t.navigate to www.haystacks.tech, right? As if you had written that in your script line of code, in your script code. Await t.navigate to with the URL. It's going to create that as if you had typed that out. Now it does that in text because that's what we do for journaling in the log. So you're going to see that in the output, in the console log output. There's the second line of code, which is the same line of code using the same data at the same time. It generates the second line of code is the actual executable that it's going to execute. So it generates it as a function. And now the function is an object that it can execute. So we're using this, so it's almost like a dependency injection pattern to inject that executable that generated, because it's generating that executable. It's generating it on demand from all this data, and it generates generates it, and then it executes it, right? So there's an execution engine component that's part of that as well. But we do the journaling, the text-based output, we do that because usually when you get into something like here with Selenium, normally when you write Selenium frameworks, you're working in Java and you've got to compile it down to a jar file using a POM and a compiler, and you know, it's a big mess, right? And then when you run it and it runs, and then it's executing, and it'll run the browser and start to do the automation, and then at some point it sits there and spins. And this inevitably happens with Selenium. It always happens. Anybody who's worked with Selenium, you know exactly what I'm talking about. It'll sit there and spin, and you sort of look at it and go, wait a minute. Let me bring my camera back. You sort of look at the thing, you as the tester or the test engineer, or you're running the test, and you sort of look at it and say, what's it doing? And maybe talk to your other test engineer. Do you see what it's doing? Do you know what it's doing? I don't know what it was doing. Or you're watching a video playback and the thing sits there and spins, and you're like, what did it do up to this point? I don't know, and I have no clue. Okay, but it broke, and it was running such and such script on such and such page at such and such time, and it's sitting there spinning, and I have no idea what happened. Well, shoot, now I guess I gotta, like, you know, set a breakpoint, go run the test again, step through the code and find out what actually happened, and hope that, you know, by doing it manually, the behavior doesn't change, and all of a sudden it works, and it's not sitting there spinning. Like, what happened? I don't know what happened. Do you know what happened? I don't know what happened. What was it waiting for? Okay, well, you know, to me, that's not even engineering. Like, that's not how engineering should be done. Okay, let me make an analogy. Let's say, for instance, you are SpaceX. The analogy being here that a rocket has a cost. A test has a cost. Now, they be orders of magnitude different. A rocket, $100 million. A test, maybe, you know, a few $100s, right? For the time that it takes to write it, for the time it takes to maintain it and service it and put all the data in and all, right? You're talking maybe a few $100s, maybe up to 1,000 for a test. But they still have a cost, right? It takes money, it takes time, it takes electricity. You have to run it on a computer or a server. That has electricity, that has cost. You had to pay for the server to begin with, right? There's all these things. Okay, so if you're SpaceX and you built a $100 million rocket, you put the rocket on the launch pad, you press the button to launch it, the rocket takes off and it explodes, right? It blows up. Complete failure, total loss, everything's gone, right? You wouldn't look at your engineer and go, did you pay attention? Were you seeing what happened? I wasn't looking. Did you happen to see what happened? No, I didn't. Well, I guess we got to build another rocket, put it on the launch pad, and this time we'll watch it closer. Is that how engineering is done? No, that's not how engineering is done. That's not even engineering. I don't even know like what that is. It's not engineering though, right? So what engineering would do is you would build that rocket, you would instrument that rocket with telemetry, right? So you would put instrumentation on all your valves, all your tanks, all your avionics, all your valves, all your pressure lines, everything, all the pumps, everything would have sensors on it that would provide this telemetry, right? And so then you launch your rocket, the rocket goes up and it explodes, and you'd look at your other engineer and you'd say, okay, something happened. I don't know what happened, but we've got all this telemetry data. Let's go look at the data, because the data is going to tell us what happened. The data is going to tell us what led up to the problem. It's going to tell us where the failure point happened, was there any contributing factors that led up to that failure, and we can do a fault tree analysis on that data and find out exactly what happened and the cascade of failures that led to the ultimate loss of the vehicle, right? That's what we need to do with testing. That's what should happen in testing. We shouldn't be setting breakpoints and stepping through code and, I don't know, did you see what happened? No, that's not even engineering. So apply proper engineering to your principles. And that's what we've engineered and designed this thing to do, is to be proper telemetry-based, data-driven triage system. So you can properly do this as an engineer would. And you can make decisions that are based on intelligent, data-driven, actionable intelligence that can drive your decisions as a tester, as a test engineer, and as a test architect or a test manager. So that's why we built this, and that's exactly what this does. So it's logging every single line of code that it does as it's doing it, and you're going to see it, exactly what it's doing. So if there is ever a failure, you know exactly what led up to the failure, contributing factors, behavior-driven, whatever was happening into there, you're going to see it. You see exactly what happened, and there's no question, right? So that I wanted to do that because when I run it, you're going to see all of this stuff being generated on demand, and I wanted to make sure you understand what it is that you're seeing. Okay, let me turn my camera off. We'll get back to the demo. So I think we've covered pretty well most of the. There's a couple other things. Let me get into. In the keywords, I think it's in here. No, it's not. Yes, it is. No. It's here. This is the login. Notice there's a password. There's a username, right? And there's these defaults. If I go into the data for the login, you're going to notice this, okay? There's a login username and a password. Now, this is the login username. Now, does that look like a username to you? No. No, it does not, because it's not. It's a long character string of alphanumeric code, right? That's because it's encrypted. This is an encrypted username, okay? And the same password, encrypted. This system supports encryption end-to-end, right? So the automation will recognize that this is a username and that this is an encrypted username, and it needs to apply a decryption algorithm to decrypt this on demand in real time to be able to submit an unencrypted username. And it's going to do the same for the password. And when it does that, there's a function built into the testing framework that's going to obfuscate what it decrypts it as. So even in the logs, this is going to show up as star, and you're not going to see it, right? So this is encrypted end to end. Also, notice there's 4 entries here in this login. Okay, we've got 4 rows. There's this right here. This first row is the developer row. This right here is the QA row. This right here is the pre-prod row, and this right here is the production row. Now we provide 4 credentials because our system is designed to work with 4 different testing environments or different environments. So most enterprise systems have these different environments that they are developing in, they're testing in, they're pre-testing deployment in, and they're actually deployed to production with. And they'll have different credentials for each of those 4 different sets of environments. This is designed to be a data-driven system. Oops, let me Control-Z that. This is designed to be completely data-driven. So the environment that you're in is determined by an environment variable on your operating system. Now, we did that because every single operating system supports environment variables. And that includes Mac, Linux, Windows, Docker, Kubernetes, right? They're all going to have environment variables. And Docker enables you to parameterize those environment variables from Jenkins secrets and AWS IAM roles, right? So we've gone all the way back to these IAM roles so you can data drive your secrets into your testing framework, and they will be completely secure end to end. Never have to give away your secrets, right? And so you can do this like that, right? And not only that, but this part right here is part of the public key. Is it that one? I think it's if it's that one or if it's this part right here. One of these is a public key. I forget which one it is. I think it might be this part here at the end is the public key. And there's a private key. And the private key can also be driven by secrets. It's also an environment variable. So the framework will combine the public key with the private key, and the private key is injected via the environment variables. So that comes from your secrets. And also, because this can be data driven from your Docker, so usually you'll have a Docker in Docker. So you use a Docker container to spin up another Docker that actually does your testing. And so that will, and usually that's driven from Jenkins. So Jenkins will determine if you're running a test in a development environment, running a test in a QA environment, or pre-prod or prod. It'll tell you, or it will determine what the environment is. So you can use that parameter to determine what credential should be used here, as well as driving those secrets. So I just wanted to specify that all of those are specifically designed to work with AWS interfaces and with traditional DevOps systems like Jenkins, Bamboo, GitLab, any of those major DevOps systems. They're all going to support basic systems interfaces like this. So yes, it is designed for that. Now let me go one step further, and let's go to here is the application. So this is the actual data that's going to be driven on the application. I come here because I want to specify that the data can also be data driven, right? So here is this is execute. These are the columns that are going to drive the interactions on the browser page when we actually get to the application page, which you're going to see. Now this is built sort of like a job application. There's a place to fill out your first name, middle initial, last name, address to, city, state, country, zip code. There's a border color to verify or do some validation with that. There's a phone number, gender, disability status, military veteran status, profile description, and then we have this company 1, position 1, start date 1, end date 1. And notice this, there's this company 2, position 2, start date 2, end date 2. Now, this framework is designed to work with interactive elements on the page, okay? And I wanted to show that specifically designed in here. So the page loads with an entry for one job history, right? Company 1, position 1, start date 1, end date 1. But there's a button there that it's going to click that will add a new position. And so you're going to see it. And when it clicks that button, it's going to add a new entry, and then it'll fill out the data for this new entry. So it can work with these interactive pages that are sort of redefined at runtime, right? The website will change based on some new behavior that's clicked, and it adds some new HTML to the page on demand in real time. And the automation will work with that. And so that's what this demonstrates. Also, there's these coordinate 1, coordinate 2, coordinate 3, coordinate 4. These are coordinates that it's going to click, XY coordinates, which are clicked for, and there's another one here, coordinate 5, that are clicked on a canvas object. A canvas object, according to automation, is just a blank square. Now, it doesn't know what is going on inside that canvas. Okay, in this case, it's a Google Maps. A Google Maps, according to automation, it just looks like a blank square. Doesn't know what to do with it. But here we're specifying click coordinates, so it can click around the screen in that canvas at these different coordinates, and it'll do that. It also works with sliders, radio buttons. You're going to see it do all of those things, right? So a lot of different things. Also, this first row of data is hard coded. So these are actual values that it's going to type straight in to the fields on the browser page. Okay, it's going to do that. The second time through, it's going to do this. Is, like I said, this is a data-driven, row-driven data framework. A second time through, it's going to execute these rules. It's got, like I said, it's a rules-based framework. So this rule is going to call faker first name, and faker first name is a rule that is going to generate a first name based on this rule. Okay, and faker is an NPM module that will generate these fake data. So it'll generate a fake first name, fake middle initial, fake last name, fake street address, fake suite number, fake city, fake state, fake whatever, country, blah, blah, blah. Okay. Company name, everything, right? That's all faker. Faker does some really cool stuff. So we wanted to make sure we include faker rules in here to generate fake data for fuzz testing or whatever, right? It's really, really great tool for doing that. But we didn't stop there. Okay. But wait, there's more. Okay, the next one is another set of rules, which in this case is generate random mixed case text by length, 10 characters long English. Okay, and here it's the same thing, randomly generate uppercase letter, 1 character English. That's going to be middle initial. And you can see it's generating these codes, mixed case text. Some of them are alphanumeric. Based on these sets of rules. These are my own rules, the framework rules that the Haystacks tech, we implemented these rules. But you can see the next one down is Chinese simplified, Chinese traditional, Czech, French, German, Hungarian, Italian, Japanese, Korean. Miscellaneous is sort of a roll-up of multiple international fonts. We've got Polish, Portuguese, Russian, and Spanish. So we've implemented a lot of different international fonts, and these things are going to generate these special characters in the Hungarian alphabet, right? It's going to do these special characters, or the Korean alphabet, like your Japanese alphabet. You're going to see all these international characters that it's going to generate. Again, on demand from this rules engine. In this case, it's going to do a Japanese first name, Japanese middle initial, Japanese last name, and then it's going to have what's this? It's going to keep, you get the position. Company name is going to be Japanese. The position is going to be a Japanese title or a code, right? These are going to be codes, but you get the idea. It's got a lot of really cool capabilities. Okay, so that's what you're going to see, and then it goes into tables, and there's all this other stuff. All right, so let's get into the actual demo. And let's see how this goes. So again, I'm going to run the Hay-CAF runner. So npm start. All right. So yeah, here we go. Okay, so here's Hay-CAF, the Haystacks Cloud Automation Framework. I didn't put instructions to the end user here, but there's an entry point for that. And then these are all the commands that the Hay-CAF runner supports. And there's a couple of them I'm going to do to sort of get things started here. And that's set execution engine playwright. Okay, success. That was configuration successfully changed. And we're going to run a workflow to do a whole bunch of changes all at once. So workflow Haystacks tech, and it's going to change us over to the Haystacks tech test environment with the actual, where the test page, it's going to set the folder paths and the root path and all of that stuff. Okay, so next I'm going to type test login. Now, when I press enter, it's going to go and find out where this login submit.csv file is. It's going to look for that because I'm not telling it login submit. All I'm telling it is login. So it's going to find this file, and then it's going to pass this file name as an argument input to calling this default.test.js in Hay-DCAF. Okay. Now, when it does that, it's going to run that in another window. It's going to spawn another process window here. It's actually going to spawn an intermediary process, and the intermediary process is then going to spawn the secondary or the next window. The reason why we do that is because we connect that spawned window with this window that I'm typing in right now. We connect them using WebSockets, and that's so I can transmit the information from the actual test back to this remote terminal, right? And we support multiple interfaces. Of course, like I said, it supports Mac, Linux, Windows. It also supports PowerShell and Bash. So we've really covered our bases here, and it's going to work just fine in Docker Kubernetes, right? You can really adopt that and work this in your system. Whatever your system is, if it's global infrastructure on a huge international AWS server suite that's spread across 6 continents, no problem at all. This will do it. This type of system is designed to scale at enterprise. So that's what we do. I'm going to press enter, and all these windows are going to pop up, plus the browser window is going to pop up, and you're going to see all of that stuff running in real time. The telemetry is going to be transmitted between the 2 windows, again, in real time, and it's a lot to see. I'm going to try to rearrange the windows so that you can see everything as best as possible as it's running all at the same time. But it's going to run through the test multiple times, as we saw, and each time it's going to generate a new browser window. So again, I'm going to try to rearrange things as it's going, and you can sort of look for it. All right, let's go. Here we go. Here comes the window. There it is, and then the browser window. So it's bootstrapping. There it goes. Okay, here comes the browser window. You can see it transmitting the information. There's that, and then you can see the stars, right? There's a bunch of stars where it obfuscated. There's the hard-coded data, interactive. There's the canvas, and there it goes. It's done. Now it's back to the table. Now here comes the next iteration. Same thing. You can see it running. Obfuscate. There was the obfuscation. And now it's doing faker names, faker data, faker city, faker company, position, coordinates, and submit. And there it is. The next one. All right. Now we're going to, I think this is the English code. Obfuscated again, stars. Here it goes. It did some negative testing on the zip code. We're showing all of the different things that you could use this for. There it goes. All right. I'm going to see if we can see the obfuscated. There it is. The obfuscated username and password. And here comes the Chinese. So there's the Chinese characters, Chinese company, description, title, coordinates, and it's done. Now comes Chinese traditional, or was it simplified? I don't remember. There it goes. The other Chinese. So clearly this absolutely works, generating this data on demand in real time from data, no code, intelligent testing automation without writing the actual script. And again, data first strategy. So this could now, an AI agent could easily be built on top of the system to do things way more reliable than what all the other QA testing automation systems in the world are doing. Because I promise you, nobody builds QA systems like this. And this can do anything. And again, it has the power for you to go customize it. So if there's something that you need that's specific, maybe you need to capture an image of the entire DOM for audit purposes, or I don't know, tracking a diff between versions of your website. This will enable you to write an engine, a rule to do that. Yep, so it's just going to keep going and going and going, and you can see this all the way till it goes to through all these languages, Portuguese and Spanish and Italian, and all the way down to Russian, right? It'll do all of that. Okay, I'm going to stop this because it's just going to keep running and running and running. Oh, I think that was Japanese. But you get the idea. Let's go ahead and call this quits here. And there it exited. It also provides, there's a test report that will run at the end. I didn't show that, but there is a test report. Let me see if I can go find it. When this thing runs, it generates a test report. And the test report is an XML format. So let me turn my camera back over. I'm going to try to bring up the test report. The test report is an XML format, and at the very end of the test, when the test is completely done, if it finishes either successful or failure, or it fails, at the very end, when it runs all the way through to the end, I exit it out so it didn't run to the end. But if you let it run to the end, at the very end, it'll take that XML report, whatever it generates, pass, fail, warning, whatever, and it will convert that XML report into an HTML report. And in addition to that, I built that as command. So it can do that for if you lost your HTML reports, as long as you've got your XML report data, then you can reissue your HTML reports or regenerate them on demand. And just you enter a command and it'll regenerate it. In addition to that, I made it so it will do it for an entire hierarchy of folders, of structures, folders. So if you've got folders that are containing all the test reports from a specific month, the month of May, the month of June, the month of July, the month of August, September, October, you might have, multiple years of many months, 12 months per year, and you've got maybe 6 years of reports that you need to regenerate reports for. You can pass that entire high-level folder. It will scan through all the sub-level folders, and it will convert all of those XML reports and then remap them to HTML reports. So you can regenerate all of them in a batch. It's batch execution. But let me come over here and let me see if I could actually find this, these reports. Trying to see where they go. No, those are logs. So it does log to log files as well, just in case you need that. I'm trying to see where the results. Yes, here we go. Okay, results logs. No, that's not it. Where is it? Execution logs. Data logs. No, I think it's under reports. Here it is, reports. Yes. Okay. So let me share my screen again. So it generates these reports, and I think these are all the login submit reports. And so this is what it generates. And so you can drill down in the keywords. This is the keyword login, partners login. And then from here, you can drill down into the individual actions and see the individual commands that were executed. In this case, that was an annotation. This one is probably also an annotation. No, that's the login button, right? And here it asserted the login title, assert exists, assert received exists. Yep. So it does all of these actions. You can do all these drill downs, and you can see when the start time and the end time are. The duration was 73 milliseconds, and the status was passed, right? So you can really drill down, as well as the individual command that was generated from this command engine, as if you had typed up that line of code yourself. Await page.select for wait for selector h2 data equals login title state visible timeout 5 seconds. Right, so you can see exactly what the thing generated and how long it took for that actual line of code to execute at the command level or at the keyword level. So it does the keyword level and it does at the test level as well. So you've really got everything you need. It's very, very, very powerful, and you can batch convert all these things. So those are the reports, but I think. These are the, oh no, I'm sorry, it wasn't XML. These are JSON. So it logs the data as JSON. And you can convert these JSON data files to those HTML reports. As long as you keep these, that can be your baseline. So all that data that's in those HTML reports, that came from these JSON data report files. And they're time stamped, right? So you've really got everything you need. You can see I was doing some testing here. These are sort of failed small files. As I was building it, you could see, and then I started to have success. So it works. I've worked on it and I've tested it and validated it, and it absolutely works. And you can see it right here. All the data is in the log as well. So if you wanted to go to the logs, you can go to the raw log outputs and archive those depending on what your business needs are. All right, so that's the end of the Hay-CAF, Hay-DCAF product stack. The next one is the Haste, which is our API, REST API testing. So I'm going to go show that, but I didn't integrate that with Hay-CAF yet. Like I said, we're about 80% or yeah, about 80% done there, maybe 90% done, but it's not quite finished. So I'm going to switch over to Haste. Okay. And from here, I'm going to bring up, let's see, where is the test command? Here it is. Okay, so from here, I'm just going to hard code the line of code that the runner would normally generate, which is long. Like, it includes a bunch of different tests. So API tests are a little bit different. They just run really, really fast. In this case, it's going to do all the same stuff that it does for the GUI testing. It's a data-driven system. I can bring over the screen a little bit and show you sort of the folder structure and sort of break this down a little bit. So it's got the same thing. These are tests, and there's a whole bunch of them. There's auth test for login, logout, refresh. There's a user ID for delete, get the user ID, put the user for creating users. There's a user here to get the users, all of the users, post. So we got all these different REST API endpoints that it can test. From here, login, logout, refresh, right? There's all of these guys. And up here, I think these are endpoint data. So the individual endpoints per test is broken down, all data driven, all CSVs. And this is the JSON data that drives those tests. So we've got, this is the body data. Body data. There's authentication. Here's the request, the response. So the response, this is the response data that should be validated, as well as the request data that drives those request entries, and the authentication for each of these. So some of them we need to test specific authentication cases. So we made sure we specify that as well. User ID versus auth for login, logout. You can do negative testing, like it does all of this, right? So it's everything that you would expect from an enterprise API testing automation framework using Newman, Postman. It's all driven from these CSV files. It's all driven with this boilerplate default.test.js, exactly the same as Hay-DCAF is what we just looked over. And these are, I've just sort of hard coded these examples. Now, again, when I run this, you're going to see basically all the verbose debug logs. So every single function or most of the functions are instrumented for telemetry. So you're going to see all the stuff that it's doing to generate the data on demand in real time using all that input data. All right. So, and then it'll run the actual telemetry. Now, when it makes the actual API call, it's going to run so fast that you're never going to be able to see it. Okay. But there is one test that is doing a high volume data test, right? So it's passing huge amounts of data, like, I don't know, maybe 1 megabyte of text or something. It's an enormous amount of text trying to pass through a REST API endpoint. And at some point, it's going to choke. When it runs that high volume data test, it starts to choke up. It goes a little bit slower because, of course, it's high volume data. And so when that API response comes back, the validation and where that data is aggregated starts to go slow. Okay. So in that case, in that one test, you're going to be able to see that HTML response, that REST API response. I'm sorry, it wasn't HTML. It's a JSON response. So in that one case, you're going to see it. All right. So you're going to have to pay attention. We're just going to watch through it, and it'll take a little while, but you'll see it. So here we go. Now, this is not going to spawn another window because that would normally be run from the Hay-CAF. And we're not doing that. We're doing it directly here. So here it goes. And there's the first API response right any second now. Is it going to run? I hope it's going to run. There. Is the APIs, did it shut down? I hope my API system didn't shut down. But it's the full verbose system. It's possible my API system shut down. It normally would run faster than this. I think it might be broken, but you can see that there now it's starting to do responses. Yep, now it's starting to respond. I think the first few was just going slow. Oh, we've got some more there. No, it's still going. It's going. Okay, here's the high volume one. This is the one that's there. See, now it goes slow. There's that JSON response body. That was the only place that you would normally be able to see that JSON response. It's very fast. If you know what you're looking for, you can spot it, but it's only for a few frames out of this very quick scrolling text. Like I said, you're seeing under the hood about how this engine works and how much work it's doing, and it's a beast under the hood. It really does a lot of work, being that it's a behavior-driven, rules-based, data-driven, keyword-driven API testing automation framework. Scaled, ready to scale for enterprise, with global infrastructure. Like this also can run on your Docker, Kubernetes, AWS, with global infrastructure on Mac, Linux, Windows. So you get a sense of how much thought went into engineering this entire system end to end, specifically for it to be able to execute and operate at enterprise scale. So there it goes. We'll see if it actually passed and see if it ran all the way through. Previous demos it did, but we'll see what it does here. The obfuscation and the decryption, they're also working here. But in this case, verbosity is turned all the way on. It's all the way up. And there it is. Yep, it did. It test status passed. And it ran for, test runtime ran for 4 seconds. Now, I think that was one of the individual tests, and this was actually a test suite. So it probably ran more than that. This is just a one report. So if we looked at the actual reports, then it would probably show. And I don't think I have the report engine working for the REST APIs yet. That was another one of the final tasks that I needed to complete to get this completely across the finish line. But it's the data is here, right? Everything is here that needs to go into the report. It's just a matter of feeding it into that JSON report. I've already done it for the GUI system, as you've seen. So doing it here is just an exercise of continuing the same thing. All right, so that's the end of that. I'm going to switch back over to the other one, and I'm going to let it run while I collect any questions. So let me switch over. CD Hay-CAF. So if you want to go ahead and post your questions, I'd be happy to. We've got a small audience here that can ask some live interactive questions. npm start. And I'm just going to go ahead and dive into this, and I'm going to start running the GUI engine just like I was earlier, and I'll let that run as I collect the questions here. Okay. Set execution engine playwright and workflow Haystacks tech. Okay, and test login. Okay, so I'm going to let that run. Move this over here. All right, do we have any questions from the live audience? Questions? Anything? I think I see some questions coming in. We're just waiting to see what they look like. So the question is, could you wrap this up into an AI-driven platform, your engine making it deterministic and reliable, the AI doing all the heavy lifting? Well, actually, the heavy lifting is being done by the framework. The AI just does the intelligence on top of that. And so you're right. And yes, this is designed specifically to do that. The main point at this point, the main thing that I need is an actual customer who can do this. I don't have any customers right now. If I had some customers, then number one, we would have a little bit of money versus no money at all. Number two, I would have data, and that's the most important thing, right? Money isn't even that important. I mean, I can work, I'll do the work, but we've got to have data. I can't develop an AI-driven framework in a vacuum. And I'm not going to just slap a ChatGPT system on the end of this thing. That's not how I work. That's not how I do things. I do things based on real world data and real world solutions. And so if I'm going to do AI, I'm going to do it in the way that is the proper way of doing AI engineering, machine learning engineering. I'm going to design it the way it's supposed to be designed. I'm not going to just slap a ChatGPT on the system. And even if I did put a ChatGPT, I would put extra layers on top to provide that AI intelligence that is needed for it to operate with proper intelligence based on this expert system and the data that it's working with, the intelligence and data that it's generating, as well as how it's the layers and that it's operating at. So it is designed to do what you asked, to do an AI-driven platform. It's designed to do that. The only reason why I haven't, again, is because I don't have the live data to work with from a customer. If I had a customer, then I could start to work with that, co-develop it with the customer. But I don't. So where can I start? I'm kind of in a chicken and egg story. I can't start on AI unless I have a customer with data that's willing to co-develop it with me. And I can't do it by myself, and I don't have a customer, so I can't develop the AI because I don't have a customer. So how do I get a customer? It comes back to that. It's a chicken and egg story. Yeah, that's kind of where I'm at, and that's why I haven't done that. Just because if I'm going to do it, I'm going to make sure I do it without just slapping a ChatGPT on the end. Okay, so the next question is, using domain-driven design, could this be automated with IDE plugins AI to pull off the domain layer to learn the business logic and generate the rules for your engine to run against? I mean, you maybe could do that. Yeah, I mean, it could have another AI layer that generates the business logic. And actually, you're going to love this. We had the other product that was planned out, which was called Hay-Plan, which is to do test plan automation. And that would sort of plan out what the tests should be at the highest level. There, it finished. It's all the way done. But let me turn the camera off and I'll sort of get back to the questions. Okay, so yes, the test plan, let me sort of describe how the test plan product would work, because that comes into your question here. I'm going to run this. Hold on. I'm going to run another script before I answer that question. Let me go workflow startup. Okay, I just wanted to run that because that's what it looks like at the startup. So, yeah. So let's see here. Okay, so the Hay-Plan product is designed to work like this. Let's say you own Ford.com, right? Good, just a generic example. You own Ford.com. And on your website, on Ford.com, you enable the user to go in and customize the vehicle that they want to purchase. Right? You want to give them the option to choose what kind of chassis type they want, what kind of body type they want, what kind of extras they want, if you want like ground effects, maybe they want a lift kit. Maybe you want a sunroof or a moonroof. Maybe you want, I don't know, maybe you want an inverter in your vehicle or a sound system or entertainment center, or, I don't know. You have all these options you can get in your vehicle. You can choose the color, the trim, the interior, if you want leather, heated seats, power everything. Like, you can choose all of those things, right? And then there's all the things that you can't choose. Maybe you are limited. You can't use for your payment options. You can't use American Express or Discover Card, right, to pay for that vehicle. Maybe you have to apply for a loan, right? And then there's delivery options and limitations. So probably no overnight delivery in Alaska or Hawaii, right? Or Puerto Rico, right? So there's certain limitations that you have to, as a business, enforce. And you got to make sure that all those features work the way that they're supposed to. Now that a user comes on to your website and they're using an iPhone 5, God forbid that an old iPhone like that, they're using an iPhone 5 with Safari browser from 10 years ago, and they're using your website, Ford.com, you want to make sure that that website works the way it's supposed to on their device, on their browser, right? And if they type in, and try to put their zip code in the last name field, then that's not a valid last name. So you need to make sure you pop up an error message. Well, you need to make sure that that error message shows up on their device, right? It can't just show up on people running Windows on a Chrome browser. It has to actually work on their device, and it has to work right. What if that person is colorblind? Okay, you can't just pop up a red outline and a red box that says blah, 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 but you can't do this. This is invalid. You have to put in a valid last name. That's not going to work. If the person is colorblind, a red box and a red outline around the field is not going to work. You need to show an X that says, nope, that's invalid, right? So they can visually see, even if they're colorblind, that that's not correct. So you've got to think about all these things, right? And that's what testing is. So you need to make sure that all those things work. Now, let's say, for instance, again, you own Ford.com and you provide all these options for your users to customize their vehicle. Let's say, for instance, you have 1,000 different options that they can choose from on your website. Now, if you want to test every single possible combination of those options, you're looking at roughly the number of tests that you're going to need to write to cover every single possible combination of those tests. You're going to need to write 1,000 factorial tests. That's how many tests you're going to need to write. Now, how many tests is that? Well, let me give you an idea of how many tests that is. You're going to need to write the number of tests that exceeds the number of atoms in the visible universe. Atoms. That's many, 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 many orders of magnitude more than the number of grains of sand, and the number of all the grains of salt on the earth across all the beaches and all the oceans of the entire planet. Okay? Way more tests than that. Now, can you write that many tests? No. Can AI write that many tests? No. Nobody, no computer, no society in the history of the world will ever be able to write that many tests. Now, even if you could write that many tests, would you be able to run them? No. You would need every computer on Earth for the next 1,000,000 years to be able to run that many tests, and you still wouldn't be able to get it all done. Okay? So even if you were able to run all the tests, how would you analyze all the data? Because the data would take up all the supercomputers in the world, plus putting supercomputers on all the planets that ever existed across the entire universe. And you're not going to be able to do that either. And then you'd be able to run all the data through all those systems, and you're talking celestial level data. It's completely beyond impossible. Okay, so how do you get the confidence that your app works with every possible combination? Listen to this. Every single defect ever discovered in the history of technology, typically on average, covers or takes up about 3.5 or 3.7 features. So you typically don't have, 100 features, a combination of 100 features to produce a bug. In other words, you don't have set this as my first name, put that as my middle initial, set this as my last name, put this as my zip code, that's my phone number, this is this, change this, choose that, this one, this, and then I get my bug, right? That's not how bugs work. Usually you have 3 things or 3.5 things, and you choose those 3 things, and then the bug shows up, right? It's typically very simple. And the exception to that might be a very complex system like the space shuttle, right? The space shuttle Challenger had a series of cascading failures that led to the ultimate loss of the vehicle. Yeah, that's a more complex system. It's going to have more complex chain of events that lead to the actual failure or the defect, right? So those are maybe exceptions, but typically applications that are built usually only have about 3.5 to 3.7 features in their defects. So if you can write your tests to cover pairs of 4, then you can significantly reduce the number of combinations of tests that you need to write. So instead of writing a billion number of tests, or trillion number of tests, you only write a few thousand. But you got to figure out what those 1,000 tests are. Well, how do you do that? Okay, glad you asked. What you do is you take that 1,000 features that you have and you assign priorities to them. In other words, priority 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. Okay, and then you take that same list of features, turn it on its head, and you assign weights. Okay, so now you've got weights and priorities. So priority weight 1, 2, 3, 4, 5, and you assign these weights. So you assign the weights and these priorities, and you bring that out, fill that out, and you've got a matrix. So now you take that matrix and feed it into a matrix solver, and it solves the matrix using a system of polynomial equations. Okay? The output of that polynomial set of equations is another matrix. Now, if you correlate that output matrix to the input matrix, you've got a test plan. And it's correlated to sets of 4. So that is how you do this. That's how you automate. You figure out what to automate. Now your test plan covers, you get 100% coverage if you implement all of these tests. But instead of a billion or trillion number of tests, you've only got maybe a few thousand, maybe 5, 8,000, maybe 10,000. But it's not a billion, trillion. Okay? How do you do that? You got to have a matrix solver. You got to build a model of your business and the features that are in your application. So that is a test plan, and that's how you automate the generation of the test plan. But then there is another layer, which is what you just asked, using domain-driven design, using an automated IDE with plugins to take that test plan, automated test plan, and convert it into actual tests and data drive the generation of this test data. And absolutely that can be done to take that test plan data and generate all these XML files, these CSV files, and then from there, one of the things that's difficult from there is the XML with the locators, the CSS locators. So that's a little bit difficult, but also can be done with an expert system. That is something that I had planned to build into the Hay-BDD. I haven't done it yet. Again, I need to work with the customer to actually be able to do that. But absolutely, it can be done, and I have built plans to build those systems and make them AI-driven. So, long answer, but I wanted to make sure I cover everything. All right, next question here is, how many lines for complete test coverage in traditional code-based testing platforms versus your platform? Python ops take roughly 1/5 the time to develop compared to other languages like C or C#. Yeah, that's true. I mean, this framework is already written. It already works, and it will. It's basically built to test most interactive applications the way they're built right now. But yeah, I mean, you don't really have to write the code because it's generating the code on demand in real time. The only thing you have to write now is those CSV files, which is just data. It's not writing code anymore. Yeah. Oh, the rules. Okay, so you're talking about the rules. The rules themselves, not complicated. It's basically writing small functions of JavaScript. They're pretty small, they're pretty simple, and they're highly reusable. You really need to have probably a test architect help you with that, at least initially. And then maybe a very high level test engineer could work up to it. But I would probably reserve that for a test architect who really has a deep understanding of how these systems are designed to work, how to get data from and where, and because we've got a data bus that forms the backbone of how data is piped through this system. And so knowing how to use that data bus is kind of important. And so having an architect, at least initially, I mean, I've got documentation that can explain how to do some of that stuff that's built in. So if somebody were to adopt this framework and purchase it as a product, then we have tech support and customer onboarding that can help with that authoring of those individual rules if you wanted to enhance the system to build your own rules. Absolutely possible, very simple JavaScript, not complicated, and we've got a rules bus that allows you to capture the data and the data flows and the data systems. So I would say it's somewhere between Python and Java and C#. It's kind of in the middle. Maybe closer to Python. It's fairly simple language. Okay. Yeah, here's a comment. It sounds like this would be a great candidate to hook into domain-driven design and vertical slices using the domain layers. Application layer and infrastructure layer, it would be great. It would be neat if the system could infer most of the details through those layers, similar to what reflection does in C#. Yes. Yeah, I mean, again, that's similar to what I had planned to do with the AI engine. And I mean, you've got the domain layer, the application layer, the infrastructure layer. This really belongs in the infrastructure layer because you build this into your DevOps system typically. That's what people have done in DevOps for probably about the last 10 years or so. And that's what this is designed to do. I would probably put it in the infrastructure layer, but it fits fairly well with the application layer because you do need to test in production. But I wouldn't build it in the application layer. The purpose of testing is to be an independent or third-party auditor of the application. So you don't consider yourself, or a tester wouldn't consider him or herself to be part of the application. They're an independent auditor. They sit aside. Sometimes they're embedded inside the developer teams, but usually that's to get them into the agile, sprint cycle, so they can test in line with the developers as the developers are building their features. So in that case, yes, it is towards the application layer or the development layer, but still very much in the infrastructure. And I should add, by the way, there's other aspects of this product. What I've demonstrated today is the QA testing framework and the driver engine. But if you adopt us as a customer, there's more than that. There's quite a bit more than that. So we've got KPIs, QA, key performance indicators that allow you to measure within your organization multiple aspects of what the cost-benefit analysis, what your return on investment is for your QA. Typically, most organizations, they will take money and just throw it at QA and just throw it over the fence and say, yeah, we know QA, we've got to do it. It's something that has to be done, and we're just throwing money at them, and they have to do it. It's part of our SOX compliance, right? We've got to do it. It's part of being ISO 9001 certified business because we have to have QA to audit, and there has to be an audit trail and all of these things, right? Just as part of organization. But as far as the money that you throw at QA, do you know how much of that money is actually being spent towards discovering bugs? How much of that is preventing bugs from getting into production? what is the percentage of what is the cost avoidance that you're getting because you're invested in your framework more. If you've put more money into your framework, then that should lead to cost avoidance. What are you measuring your cost avoidance? Do you even know how to measure cost avoidance? Right? We have KPIs that are built into our enterprise product offerings, so we provide those to you. In addition, that we have also built in some things around agile project management that teach you as a project manager or as a business executive how to measure your agility of your teams. So this is the agileness. How agile are your teams? In other words, how well is your teams implementing agile within your organization? Do you have a way of measuring that? Do you have KPIs around it? Are you measuring it on a consistent ongoing basis? Are you measuring it on an individual actor level? In other words, do you have those metrics for your managers? How agile are your managers? How agile are your developers? How agile are your testers? You need to know these things if you're operating an enterprise business that's supposed to be operating in agile. You should be able to measure that stuff. You should be able to look at those numbers and know what they are, especially as a business executive, right? That indicates how much of your money is being wasted if you're not following agile, but you're supposed to be, right? So you need to know those things if you're running a business. And we provide that as well as part of our offering. It's just built into, if you purchase this product suite, you're going to get that by default. We just provide it. You don't have to pay extra for that. Yeah. So, sorry, I got off on a little bit of a tangent there, but you brought up a good point. So, anything else? I think we need to wrap this up. If there's any last minute questions. No? Nothing last minute? Okay. Yep. Let's call it quits. I think that was really good for tonight. I thank you so much for your time. And if you have anybody that's watching this later, if you have any comments or additional questions that you'd like to ask, drop them in the comments section below. I will be happy to answer and I will be on point. Or send us a message. You've got all our socials, Haystacks Tech on X. You can ping me there. You can also ping me on LinkedIn. I probably won't check LinkedIn. There's just too much garbage on there. I would say, maybe send me a message to my LinkedIn email. That's probably not going to work either. Let's see here. What's another good way to reach me? We've got, probably X is about the best way. Ask if you want to stay connected or get connected here on YouTube. I've been kind of disengaging lately, but if you're very interested in this product, I would be very much interested to talk with you. So reach out and get connected somehow, right? I will, if you are persistent in connecting with me, then I'll make sure and follow up with you. So look forward to talking with you soon. Take care. God bless. Have a good day. And we'll see you later. Bye-bye.